My theme of seminar Planetary Exploration is about Mars. I accept you have already common knowledge about Mars, for example about radius, weight, rotation period, and so on. In books I've read always, numbering of Mariner, Viking, or Phobos, or Sojourner, which have found this fact or sample. In other words, which mission gained which records of Mars. Therefore, it interested me to which science goal are Martian mission working on. So I'll explain now which science goal there are and which acquire we have gained already. The idea of science goal is from NASA, like following slide. There are 4 aims: life, climate, geology, and human. About life, Mars and Earth have similar early history, and H2O is found also in Mars. Therefore, Mars has a high potential for prior or current habitability of life, which fact we already know is by Viking lander analyze volatile substance with following experiment. There were no fragments of organic molecules which apart from CO2 and some H2O detected. On the other hand, microbiological experiments which should respond to gas exchange, metabolism, or carbon assimilation didn't result in a clear decision between biological or chemical activity. About climate, it is slightly difficult to categorize the theme of climate, but now I'd like to categorize seasons, atmosphere, and ice age as the theme of climate. About seasons, Mars has also 4 seasons like the Earth. At spring exists at southern hemisphere large dust storm, typical 200 to 300 in diameter, and tend to occur at 2 to 3 p.m. in local time. At summer, are surface winds low. At northern solar cap is sublimited CO2 ice. It causes to rise Martian atmospheric pressure up to 25% more than other seasons. But by southern polar cap not, because H2O ice is covered over CO2 ice, so that CO2 ice by southern pole is held. Maximal temperature is minus 33 degrees, and it will be cooled down evening until minus 83 degrees. At autumn, because winds are a bit stronger, and at winter rise dust storm up to 20 to 30 meters per sec, frost deposit is covered over Martian surface. About atmosphere, Martian atmosphere is very tiny, about 0.007 bar. They are mostly of carbon dioxide, nitrogen, and argon gases. These are also weather in Mars. Now I'll explain especially about clouds. There are 3 major types about Martian clouds. First is clouds of dust, in the other word, dust storm. Second, clouds by water ice, like Earth's water cycle. Third is by carbon dioxide from bales of dry ice. About Ice Age. Mars is now in Ice Age. You can understand it from explaining about Martian summer temperature. Last time, when Mars with warm climate was about 300 million years ago, and we suppose now, end of this ice age is after 1 million years. In trend, there are always short warm era in Mars. Mars is cooling down now. About geology. Geology is main theme of Mars researching, so I'll explain it in next slide. About humans. Goal is like Apollo mission on the Mars. To reach this goal, we need correct knowledge of cost, risk, and performance. With this data, can we design and implement a human mission by Mars orbit, surface, and moons? About geology. About Turian. The background picture of this slide is about water channel Turian of Mars. Martian Turian comprises 5 major divisions: highland rock, lowland rock, volcanic regions, channel systems, and polar regions. About crust. Martian crust doesn't have homogeneous thickness. 40 km thick in northern hemisphere and 70 km thick in southern hemisphere. Thickest area lies under the Thesis volcanoes and thinnest area is at Giant Hellas. About volcanic. There are 2 major volcanic areas. First one is Thesis. It includes Olympus Mons, which is the largest volcano in our solar system. Second one is Elysium. This place is very important with Martian Valleys Valley Network, one of evidence of a subsurface lake of ice beneath the soil. Volcanic activity is not so active like Earth today. Accordingly, Mars doesn't have strong magnetic fields now. About rock. Main rock in Mars are basalt and andesite, which are enriched in oxides and sulfides. Martian meteorites are often basalts with pyroxene olivine. There are 3 famous magnetization also: magnetite, titanomagnetite, and margemite. About surface. Northern surface of Mars is basaltic and southern surface is andesitic. Martian surface behavior changes alien environment always with seasonal dust storm. About mineralogy. Dominant silicate minerals are olivine, plagioclase feldspars, pyroxenes, and quartz mixed with titan iron oxides. About Moon. I'll describe about Moon in 5th slide. About history. There are 3 major eras in Mars: Noachian, Hesperian, and Amazonian. In next slide, I described about early Martian condition with some aspect from this slide and last slide. Earliest record of Martian history is Pre-Noachian. It began the formation of Martian crust at some 4.5 billion years ago and ended at 4.1 billion years ago. About Turian. This period is assumed the creation of the vast northern flat lowlands, now named vastitas borealis. At the same time, the rugged southern highlands is also created. About climate, through asteroid or comet impacts and outgassing of planet's mantle is the initial very dense atmosphere created on Mars, and the climate started cool down. Eventually, the water vapor in the atmosphere behaves like a pressure cooker around the Mars, so that a vast ocean exists. Slowly, this large body of water started to cool down, resulting in a first window for the possible emergence of life around 4.4 to 4.3 billion years ago. Since then, much of the atmosphere has escaped into space or become incorporated into the surface as the planet inexorably cooled. Following period, named Nocean, which is 4.1 to 3.7 billion years ago. Nocean was a period of heavy bombardment with numerous asteroid and comet impacts. The largest impact structures still visible on the planet today, often in southern highlands like Hellas and Argyria basins. About volcanoes. At the same time, large-scale volcanic activity was in the Tharsis region and parts of the highlands. For example, through growing of Tethys Barrage exist some of the largest volcanoes in the solar system, as Alzia Mons, Pavonis Mons, and Asclepios Mons. At the giant reefs of surface is valley system of Valles Marineris. About climate. Through the volcanic eruptions was warmed the planet with ash and gases, at the same time developed precipitation probably, because many of the valley networks and lakes seem to have formed in many basins and craters. There were a shallow ocean covering at least part of northern lowlands. It led to the formation of clay minerals with non-acidic groundwater, known as phyllosilicates. Habitable environments gradually became smaller and more localized, but there should live any life on the Mars. After Nocean period follows Hesperian age. It lies between 3.7 to 2.9 billion years ago. In this age, were impact cratering rates significantly lower and global geological activity also slowing down. Because of still considerable volcanism, had at least 30% of Mars resurfaced during this period. By erupting volcanoes were huge amounts of sulfur dioxide and water emitted. They reacted to make sulfuric acid, which then rained onto the surface, especially by Valles Marineris and Meridiani regions. About climate. It became colder than Nocean, and much of water probably became locked up as permafrost or subsurface ice. Because of heating surface during eruption or impacts, it happens often flows on this period. We can know those water hazards around the edge of Cris Planitia and eastern Hellas Planitia, or along the Valles Marinalis system. These 2.9 billion years called Amazonians. This age has a relative absence of large-scale geological and climate change, and Martian surface become dry and arid. By following slide, I'll describe about Martian moons. There are two moons with irregular form around Mars, Phobos and Deimos. They have following characters. About Phobos. Basic knowledge about Phobos. Orbital period is 7 hours 39 minutes. Size is 27 times 21 times 19 km, and distance to Mars is only 2.8 times mass radian from Martian surface. Density is 1950 kg per cubic meter. Phobos is nearing Mars at a rate of 1.8 meter every 100 years. At that rate, it will either crash into Mars in 50 million years or break up into a ring. Phobos has only 1/10 as much gravitational pull as Earth. For example, a 68 kg person would weigh 68 grams there. About Deimos. Orbital period is 30.3 hours. Size is 15 times 12 times 11 km, and distance to Mars is 7 times mass radian from Martian surface. Deimos has more distance than Phobos, but it's still closer than distance between Earth and Moon, which about 130.4 times mass radian. It runs from west to east and very slowly, staying above the horizon for almost 3 Martian days and passing through all phases several times, with the same hemisphere always facing Mars. The craters on Deimos' surface are more subdued than those of Phobos, suggesting that it is covered in a layer of regolith even thicker than that of its neighbor. It is two prominent craters, Swift and Voltaire. About two common themes of moons. First, those of the Viking mission show signs of heavy meteorite bombardment on both satellites. Second, they share the following two theories, which describe origin of Martian moons. First, the pair of moons are asteroids. They had been captured after the formation of Mars. Second, the moons are fragments scattered during giant impact with mass that then coalesced. Background picture of this slide is imaged by giant impact theory of moons. By last slide, I present you new Mars project, which should bring us new Martian condition knowledge. MMX is new Martian project, which is led by JAXA with NASA, ESA, CNES, and DLR. Departure is in next year, and it will be returned to Earth at 2029. Main mission of this project is to get objects from Phobos and return to Earth. Earth has a thick atmosphere, so that most of meteorites are burned out through atmosphere. But Mars has only tiny atmosphere. Therefore, most of meteorites attack on the surface, and Martian fragments should be spread on Phobos. There were also two big impacts in last year on Mars with Marsquake. Scientific aim is to research origin of Martian moons and evolution of Mars, Phobos, and Deimos, and possibility of operation by Phobos as a natural space station. There are three big expected subjects. First, find most likely theory of the moon's formation, like last slide. Background picture of this slide is imaged by captured theory of moons. Second, Martian atmospheric material circulation and dissipation related to the Martian surface environment and climate change. Third, next step to understanding the evolution of the pre-life environment as the condition that led to the birth and sustenance of solar system life environment.